Welcome to Trump Wire, your trusted source for breaking headlines, global insights, and sharp analysis from around the world. If you're new here, don't forget to hit that subscribe button and turn on notifications so you never miss an update. In the fast-paced world of technology, some stories go far beyond the excitement of new product launches. They have the power to reshape the entire industry landscape. These are the moments when speculation, anticipation, and innovation collide, sending shockwaves through boardrooms and newsrooms around the globe. Right now, the tech world is buzzing louder than ever about Huawei's rumored Kirin 9030 chip. Whispers suggest it's being built on a process equivalent to 3 nanometers. A level of miniaturization and efficiency that only a handful of companies worldwide have ever achieved. If these rumors are true, it would mark a dramatic leap forward for Huawei and for China's semiconductor ambitions. The potential impact is enormous. Such a breakthrough would represent a seismic shift in the global semiconductor industry, challenging the years-long dominance of a select few players in the US, South Korea, and Taiwan. It could disrupt established supply chains, alter the balance of power, and force competitors to rethink their strategies. For Huawei, a company long seen as a casualty of US sanctions and global trade restrictions, this could be the ultimate comeback story. It's not just about survival. It's about redefining what technological self-sufficiency means for China. A successful launch would send a powerful message to the world that innovation can thrive even under intense pressure. The ability to manufacture advanced chips is the bedrock of modern innovation, powering everything from smartphones to artificial intelligence. If Huawei truly cracks this code, it would force the world to reconsider the effectiveness of tech sanctions and the future of global technology competition. Adding to the intrigue, the rumor mill hints at a gaming-focused smartphone debuting in early 2026. This would be a bold move, signaling Huawei's intent to compete at the highest level in a market dominated by established giants. It's a statement of confidence and a challenge to the status quo. The implications of these developments are massive, not just for Huawei, but for the entire global balance of technological power. Governments, investors, and consumers alike are watching closely, knowing that the outcome could reshape alliances and redefine the future of innovation. Ultimately, this is a story of defiance, relentless innovation, and a nation's ambition to lead. All of it, for now, is sparked by one powerful rumor, one that could change the course of technology history. To understand the hype around 3nm chips, let's break down what this technology really means and why it's such a big deal in the world of electronics. When you hear 3nm chip, you're hearing about the cutting edge of semiconductor manufacturing, a level of miniaturization that was once thought impossible. The term nanometer refers to the size of the transistors inside the chip. A nanometer is just 1/1000th of a meter, so small that you'd need tens of thousands of them to span the width of a human hair. The smaller these transistors get, the more you can pack onto a single chip, which means more computing power and greater energy efficiency in the same space. Shrinking down to 3 nanometers is a massive leap forward. It's not just about making things smaller, it's about unlocking new levels of performance, extending battery life in our devices, and enabling advanced features like artificial intelligence and real-time data processing. Imagine your phone running faster, your laptop lasting longer, and your smart devices becoming even smarter, all thanks to this tiny technology. Packing billions of transistors onto a chip the size of your fingernail is a feat of engineering. Each transistor acts like a tiny switch, turning on and off to process information. The more you have, the more calculations your device can handle at once, making everything from gaming to scientific research faster and more efficient. Achieving this level of miniaturization requires extreme precision. Manufacturers use advanced lithography techniques to print circuits that are just a few atoms wide onto silicon wafers. This process is so delicate that even a speck of dust can ruin an entire batch of chips. The industry standard for making these chips is called extreme ultraviolet, or EUV, lithography. This technology uses incredibly short wavelengths of light to etch the tiniest patterns imaginable. EUV machines are among the most complex and expensive tools ever built, and they're the bottleneck for global chip making because only a handful of companies can make or operate them. Without EUV, producing a true 3nm chip is nearly impossible. The process demands not just advanced machinery, but also world-class expertise and a spotless manufacturing environment. That's why the race to master this technology is so intense. It's not just about making better smartphones, it's about dominating the future of artificial intelligence, powering massive data centers, and enabling breakthroughs in everything from healthcare to autonomous vehicles. Whoever controls 3-nanometer chip technology will have a huge advantage in shaping the digital world of tomorrow, influencing everything from global economies to national security. For Huawei, breaking through this barrier would represent a generational leap, a chance to redefine its place in the tech world and challenge the current leaders in chipmaking. That's why the world is watching so closely. Every announcement, every breakthrough, and every setback is headline news, with the potential to shift the balance of power in the global tech industry. This isn't just a minor upgrade or a simple spec bump. It's the dawn of a new era in innovation, one that will shape the technology we use for years to come. So why can't Huawei just buy the tools to make these chips? Enter geopolitics. Only one company, ASML in the Netherlands, makes the EUV machines needed for 3-nanometer chips. US-led sanctions block ASML from selling this tech to China, including Huawei and its partner, SEMIC. This creates a wall. Huawei can't follow the same roadmap as Apple or Samsung. Even older deep ultraviolet DUV tools are now restricted, tightening the squeeze on China's chip industry. The goal: maintain a technological gap and slow China's progress. For Huawei, overcoming this blockade isn't just about engineering, it's about rewriting the rules of the game. The EUV wall is the central challenge, and breaking it would be a historic feat. Most wrote Huawei off, until the Mate 60 Pro launched in 2023 with a surprise, the Kirin 9000S, built on a 7-nanometer process. This was thought impossible under sanctions, but Huawei and SMIC pulled it off using older DUV machines and a complex technique called multi-patterning. It was less efficient and more expensive, but it worked, proving sanctions could slow but not stop Chinese innovation. The Kirin 9000S wasn't the fastest, but it brought 5G back to Huawei phones and showed the company's resilience. This comeback stunned the industry and set the stage for today's 3-nanometer rumors. If Huawei could do 7 nanometers with DUV, what else might they be working on? Their success proved underestimating them is a mistake. The world started paying close attention. The 7-nanometer feat gave the current rumors credibility. Huawei's story became one of relentless, creative problem-solving. The tech world is abuzz with speculation about the Kirin 9030 and its so-called equivalent 3-nanometer process. Headlines and forums are filled with debates, and everyone wants to know, what does equivalent really mean in this context? Is it just marketing spin, or is there real innovation behind the claim? The wording is crucial here. Most sources are careful not to say it's a genuine 3-nanometer chip. Instead, they emphasize that the Kirin 9030 is designed to match the performance of chips built on true 3-nanometer nodes, even if the underlying technology is different. The most likely scenario is that Huawei and SMIC are pushing deep ultraviolet, or DUV, multi-patterning techniques to their absolute limits. They're probably achieving something between 7 and 5 nanometers in terms of physical process, but then squeezing every bit of efficiency out of the chip's architecture through clever design and optimization. This is a case where design innovation is being used to compensate for manufacturing limitations. By rethinking how the chip is structured and how its components interact, Huawei's engineers are able to close the gap with competitors who have access to more advanced fabrication tools. Meanwhile, by 2026, industry giants like Apple and Qualcomm are expected to be producing chips on true 3-nanometer or even 2-nanometer nodes, thanks to their access to extreme ultraviolet or EUV lithography. This means the gap in raw manufacturing technology will only widen. Realistically, the Kirin 9030 will likely perform on par with the Snapdragon 8 Gen 2, or maybe even a Gen 3. That's still a massive achievement considering the manufacturing constraints Huawei faces. It means users can expect flagship-level performance in most real-world scenarios. While it may not claim the title of the absolute fastest chip on the market, the Kirin 9030 will be more than competitive, especially in gaming phones, where sustained performance and efficiency matter just as much as peak benchmark numbers. The equivalent label is all about achieving target performance levels, regardless of the path taken. It's a testament to the ingenuity and determination of Huawei's engineers, who are finding new ways to deliver cutting-edge results. This approach is both pragmatic and creative, a way to stay in the global tech race even when the odds are stacked against you. It's about making the most of what you have and refusing to be left behind. For Huawei, that's more than enough to keep the world watching, and to keep the competition on its toes. Excitement aside, experts remain skeptical. Building EUV tech from scratch is a monumental challenge. ASML took decades and a global supply chain to get there. Most analysts think equivalent 3 nanometer is a marketing term, not a technical breakthrough. It's a smart way to hype the chip without overpromising. Even if the Kirin 9030 matches last year's flagship chips, it's a major win for Huawei under sanctions. The real story is relentless progress, not a miracle leap. The Kirin 9030 is just one piece of Huawei's bigger plan. Beyond smartphones, Huawei is dominating the foldable market, holding nearly half the global share by late 2024. Their innovation in hardware keeps them relevant, even with chip constraints. But the real long-term play is in AI and enterprise. Huawei's Ascend and Kunpeng chips are targeting data centers and AI, directly challenging giants like NVIDIA. They're building their own high-bandwidth memory and server CPUs with hundreds of cores. This isn't just about phones. It's about controlling the entire tech stack, from pocket to cloud. Huawei's ambition is to be a vertically integrated powerhouse. That's why every chip breakthrough matters. The stakes are much bigger than a single device. Launching the Kirin 9030 in a gaming phone is a strategic move. Gaming phones are the ultimate test, demanding peak performance and efficiency. If Huawei's chip can deliver smooth gameplay and great battery life, it's a marketing win. This shifts the conversation from specs to real-world experience. The gaming market is huge and growing, with dedicated fans willing to pay for performance. A successful launch would rebuild Huawei's brand in the high-end space. It's a bold way to prove their chip strategy works. If the Mate 80 GTS succeeds, it signals Huawei is back and ready to compete at the top. So, is Huawei's rumored chip a game-changer or just hype? The truth is, it's both. The real breakthrough is Huawei's ability to keep innovating under intense pressure. The 3 nanometer label is likely marketing, but the engineering progress is real. This forces a global rethink. Can sanctions really contain technological ambition? The world is watching for the Mate 80 series launch and the first teardowns of the Kirin 9030. But the bigger story is China's relentless push for self-sufficiency. Whether this chip is a revolution or just a step forward, the race for tech leadership is on.